Hello there. In this lesson, we're going to learn how percentages can be used to compare the amount of yield that you have compared to perhaps a theoretical amount, how pure something is, and how far off an experiment might be from an accepted or theoretical value. So purity has to do with like a substance that you might be a reactant or something that you are making, like an alloy. Error could be like the result of a reaction where you're losing some of your product and you might be off the measured quantities that you get might be off the amount that you're looking for. And yield is talking about the amount of product that you actually end up with. And so with this experiment where you're burning a piece of magnesium, it's that white powdery magnesium oxide that you end up with. So the first quantity we're going to look at here is called yield. Yield refers to the amount of a product that you get. A classic reaction we do in chemistry class is with some steel wool and copper sulfate in solution. And if you react the two of those, you'll end up with a solid copper product that is made. And so you would say that that was the yield of the experiment. You can calculate the amount of the yield and get a theoretical quantity. So if all of this steel reacted, you can, if you start off with 10 grams, you can work out that you should get 11.4 grams of this product, and that would be your theoretical yield. And then when you actually measure it, you collect it in a filter paper and let it dry and rinse and all that stuff, that will be your actual yield. That's what you actually got in the lab. So this is actual, and this is theoretical. So to compare the two, you can use a percentage. You just put the actual amount that you found in your lab activity and you divide it by the theoretical amount that you calculate times 100 gives you a nice percentage. In this example, we are expecting 20 grams of product from our calculations, but we only got 15 grams in the actual lab activity. And so that's going to work out to be a 75% yield. All right, here's one to try. In the experiment, 10 grams of pure magnesium is reacted with excess oxygen and 9 grams of magnesium oxide is collected. What is the percentage yield? Well, we've got the actual, right? We worked out the amount that we actually collected. And so now we need a theoretical amount. We know we started with 10 grams of magnesium. So we want to know the mass of magnesium oxide that we theoretically should have gotten. So we'll take our 10 grams of magnesium, and then we're going to change that into moles, right? Grams per moles of magnesium. And then we're going to use the ratio, which is a handy 2 to 2 here. So 2 moles of magnesium for every 2 moles of magnesium oxide. And then we need a mass, so magnesium oxide. Magnesium is 24, oxygen 16, so those would add up to 40 grams per mole of magnesium oxide. And we'll make sure everything cancels out here. Grams, grams, moles, 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 moles. And what we work out is, let's see here, 10 divided by 24 times 40, because the 2's cancel out, end up with 16.7 grams. So that would be our theoretical amount. So to get the percentage yield here, we take our 9 grams of actual divided by the 16.7 grams of theoretical times 100. And our percentage will be 9 divided by 16.7 equals, I've got 54%. Yay. All right, so why isn't it always 100%? Well, there's a whole bunch of reasons. One could be an incomplete reaction. Maybe there isn't quite enough of a certain reactant. And you'll get something like incomplete combustion, where you're not going to get all of the product that you're hoping for. Another is side reactions, where the thing that's reacting might also react with some other things that are nearby. So an example is what happens to create this nice greenish color on brass statues. And they always end up kind of greenish, like the Statue of Liberty. And it's because the copper will react with oxygen. You get kind of a reddish color, like on old pennies sometimes. And then that copper oxide will react with more oxygen, and you get this black stuff. And then that copper oxide will react with some water and some carbon dioxide, and you'll get this complex as well, which is kind of that greenish tint, right? So you can get any combination of these things happening at any point in time, and you'll end up with a combination of products. And so therefore your yield wouldn't be 100% for any of these things. The other thing is experimental error. If you're doing something in a lab and you haven't controlled for all of the variables, sometimes there's going to be problems with your lab setup that mean that you won't get 100% yield. Alrighty, purity is another thing that can be expressed as a percentage. Jewelers will use carats to express this, but the carat system is also related to percentages. So the carat system goes from like 0 to 24 for gold anyways, where 24 karat gold is 100% gold, and 12 karat, like this ring here, is only about 50% gold, and down from there, right? So you can do that just like any other percentage. If you have 10 grams that is impure and it only contains 8.2 grams of actual magnesium, well, the percent purity equals the 8.2 grams that's actually magnesium over the 10 grams of the impure metal that includes some magnesium. And of course, you'd end up with 82%. So that shouldn't be too hard to follow. Sometimes it won't be given to you as straightforward as that. You might have to do a little work to figure out what the pure part is. So we took 13 grams of this impure magnesium and then reacted to produce this magnesium oxide. So assuming that it was 100% yield, that we have worked all the kinks out in our experiment and knew that we could get 100% yield, we could work out how much of that 13 grams is actually pure magnesium. So we'll work backwards. We want to know the mass of the magnesium that was actually pure, and we'll take the 15 grams of magnesium oxide, and we'll do stoichiometry backwards to get the mass of magnesium. So if you recall, it was 40 grams per mole for magnesium oxide, and then the ratio again was 2 moles of magnesium oxide to 2 moles of magnesium, and then magnesium by itself is 24 grams per mole. And so that comes out to, let's see here, 15 divided by 40 times 24 equals 9. Oh, nice and even. So 9 grams of pure magnesium in that 13 gram sample, and so the percent purity would equal 9 grams of pure divided by 13 grams of impure, and times 100, and that comes out to 9 divided by 13 times 100, 69% pure. All right. Finally, whenever you set up an experiment, there will likely be some error associated with it, because it's very difficult to set up a perfect experiment, especially in high school. And so there's a way to express how close your experiment get to some theoretical or ideal value. So you might see this from time to time. And then in order to calculate how close you are, a percentage error can be worked out. And this time you're looking at the difference between what you got in your experiment to what you theoretically should have had based on some ideal value. So you subtract the two of those, get rid of any negative signs. That's what these are, like absolute value signs, and then divide by the theoretical value. Okay, so let's give this one a try. If a theoretical yield is 45 grams of a product and you actually got 38 grams of a product, what is the error percentage? So we will put in the experimental value here, 38.8, and we'll subtract the theoretical value, 45.0, and that's going to be a negative value, so we're going to get rid of that. And then divide by 45.0, and let's see what we end up with here. 38 minus 45 equals that, divided by 45 equals, and I got 15.5.6, I guess, percent. Oh, times 100. There you go. 15.6%. So yeah, it's just the difference between your actual or your experimental value, and the theoretical one. Okay, hope that helps. We'll see you soon.